All right, guys. Guys, a very quicker video over here. Um, so the topic is going to be called higher order derivatives with implicit differentiation, guys. So I'm just going to show you one example of this, guys, and kind of let you guys to practice these ones over here. So the question is saying, calculate the second derivative of x cubed plus y cubed equals 9. Okay. So first of all, the first derivative, take the derivative of both sides of the equation. We get 3x squared plus 3y squared dy dx equals 0. Okay, and so then we just divide. We have dy dx equals negative 3x squared over 3y squared. The 3's cancel out. Okay, so our second derivative we need to calculate here, which is going to base that off of our first derivative. I'm just going to attach this negative to the numerator in this case. So our second derivative is d squared y dx squared. There's our second derivative. We have to use quotient rule in this guy. Bottom, top prime, y squared. Derivative of negative x squared is negative 2x minus top bottom prime. So here's where it gets a little bit tricky. When we have to take this, our second derivative now has a first derivative in it. Okay, and then bottom squared, y squared squared is y to the fourth. Okay. All right, so the trick we're going to do here is we want to get rid of this dy dx in our second derivative. And we're going to do that by, well, we know that dy dx is equal to negative x squared over y squared. So we're going to make this substitution in here. So negative negative is going to be a positive 2x squared y. Now dy dx is negative x squared over y to the fourth. And we get this cancellation here. Guys, I made a mistake. Sorry. We still have 1y down here, 2x to the fourth over y to the fourth. Is that right? There we go. Okay. Here's going to be our next trick here. One thing I can do here, like this is kind of awkward to have like a fraction over a fraction like this. I'm going to multiply the top and the bottom of this fraction by y. And this is going to give me negative 2x y cubed minus 2x to the fourth all over y to the fifth. Guys, I need a second screen over here. All right, so we can simplify this guy a bit further. In our numerator, we have a common factor of negative 2x. Okay, so This is what we're at left so far. Now, the other thing is, which happens often in these questions as well, is if we looked at our original equation, it was x cubed plus y cubed equals 9. Okay, so now this 9 is going to replace this y cubed plus x cubed over here, which equals negative 2x times 9 over y to the 5th. And this would be our fully simplified version of this guy over here. All right, guys. So it's kind of how this last example works over here. Definitely a bit of work taking the second derivative when you're doing implicit differentiation as well.